Thank you very much. Keep hearing little messages in my ear, which is a good thing. So yes, thank you very much, Ruth. Thank you for the opportunity to come and speak to all you lovely people out in industry. My name is Tristan Prager, and I'm the sales manager international for a company called ATI. It's probably a company you've never heard of, although I did see some of the company names on the list of attendees, and I do recognize actually some of the people. So it's a great opportunity for me to introduce my company, our company, and to offer solutions to issues that obviously are coming up to fruition nowadays. So a little bit about the company I work for, just to get us going. ATI is a company that manufactures water quality sensors and gas sensors. We're based in America, and I'm based in the UK, in Manchester. I've been with the company 19 years, nearly 20 years, and we are very, very big in the water industry. We dominate the water industry in the UK, but we've never really focused on industrial work, and that's something that we really want to put right. So we're looking at adopting a lot of the solutions that we make, that we supply into the water industry, to push that out into industrial use as well. Because there's lots of solutions that we make that, especially nowadays, are needed to optimize control and process within a business, and of course with the gas sensors too, to improve health and safety. So I look forward to a string of webinars where we can help you out in industry improve, make things more efficient, and improve health and safety. So today's segment is about the HVAC market. And the reason why I wanted to tackle this sector first is, of course, the need to really save money on power. We've spent quite a bit of time on the HVAC market as a diversification into the water industry. And we were recently acquired by a large company that make flow meters. So flow metering is a big part of the HVAC market, and I've thrown a few slides in today. And I would really, really love some great questions at the end, so we can see if we're making the right steps. So the importance of water quality sensing in the HVAC market. So for the novices out there, what is HVAC and what is the market? So HVAC stands for heating, ventilation, and air conditioning. And as we know, it's vital within buildings and offices to maintain good quality hot and cold water in the systems. And we look, especially from our point of view, when we deal with the water companies, we make products that make good quality food, i.e. water at a treatment plant, and then we push that water into an old network of pipes and the water quality changes. So when we look at things like chlorine and turbidity in a water network for a water company, we look at different parameters in a network inside a building. And that could be therefore the ventilation in the factories that you work, the buildings that you work, the offices that you work. And ventilation is used to take out dirty air and replace it with clean air. We call it air changes. So potable water is brought in, and this is the water that we've helped treat at the water companies. Chemistry is added, inhibitors, oxygen scavengers, and then it's maintained by a third party or by your own company, okay? So it's very important that we keep an eye on that water quality. The industry for HVAC is massive, it's huge, and includes all the buildings that you can think of, from shopping malls to hospitals to MOD, schools, etc. So the HVAC market is huge, and especially now, when we look at things like the viruses, like the COVID-19 issues, and more importantly, I think, Legionella risks in hospitals from water that may not have the correct biocide level to kill the bugs. So why measure water quality? Why is it important to measure water quality? Well, again, by taking care of the water in the applications in the buildings, it's vital to understand a healthy network. You could look at things like risk of failure on a building. If a big pipe breaks because of corrosion in a network, it can be millions and millions of pounds of issues. Insurance premiums could go high. Obviously, the water quality is bad. There could be issues, especially with cooling towers and open loops. Risk of Legionella has always been an issue globally, not just in the UK. So if we can keep an eye on the water quality, things like the pH, dissolved oxygen, conductivity, and then all the biocidal sensors, we can reduce the risk of bugs, including Legionella, Pseudomonas, and also microbacteria. So understanding the water quality in a building is reducing the risk of corrosion, reducing the risk of failure, big issues with flooding, and of course, understanding the chemistry to make sure that you've got the right chemicals in there, but also to control bugs with biocidal sensors. And now we've been acquired by Badger Meter. You know, we can also look at the flow part of it as well as the quality. So the quantity with flow and the quality in terms of water quality. So flow measurements are crucial, again, for users to understand a bit more about how the water is being used in the applications. Changes of flow could indicate different situations like leaks, like backflows, like air in the system, and all the information as normal from flow metering and also water quality can be sent to a SCADA system, all the normal functionality that you'd expect in this era. And also alarms on there as well, because if you're bringing too much flow in, then the question is why? You know, these are usually pressurized systems. You shouldn't be bringing lots of water in. You may get a bit of condensation, but ultimately you shouldn't be bringing too much water in. So we can ask the question why with set alarm points. So looking at some of the applications that I've been looking at over the last few years, and some of these applications you'll hopefully be aware of in your areas, we'll start with the closed loop system. And these are hot and cold areas, coolers, boilers. We have the water going out and the water returned. And these closed systems are under pressure. And one of the biggest things that we need to do to reduce the risk of corrosion is to reduce the dissolved oxygen in the system. And many companies add scavengers, things like sulfites, to the system to reduce the oxygen levels. These systems are under pressure. And so running water past sensors and putting it back into the system requires a differential of pressure. We use at least half a bar of differential of pressure to push that water back in. And if you were to use a pressure sensor, and you could therefore use water quality and pressure, you could have a full suite of parameters that you therefore understand if there was a potential of a leak or soon to be a burst. So we look at the closed system, the closed loop system in your building, in your premises, as a very small version of a network out there in a water industry. And of course, we use sensors like you can see on these pictures for measuring continuous, accurate water quality in a network. So it's a very small version of what we already do. And we have some great examples of these closed loop systems and open loop as well. And of course, with an open loop, you've got the risk of oxygen getting in there, which therefore feeds bacteria, and you've got the potential for Legionella. So we have to look at both closed loop systems for the system to be reduction of corrosion, but we also need to look at the open loop. Now, the pictures you see on the right-hand side are of a building in London. The first one with the blue panel is a system that we make, and the sensors are multi-parameter. They're modular, so you can add and take away the sensors if you wish. And the Modbus low-powered sensors, so they can be fitted anywhere on a network in a building, collecting data continuously with alarm set points. And even if you haven't got power, we can use a small battery that will feed the unit for up to a year. So the picture you see on the right-hand side, the top one, is of a cooling tower in London. And they're using ozone, dissolved ozone as the biofilm. And they wanted to make sure they've got a residual up at the cooling tower to make sure there's a reduction in the risk of Legionella. So you can see the blue sensor, you can probably make out DO3, dissolved ozone, and then we have pH and we have conductivity. So pH and conductivity are used to make sure that the inhibitors that you use remain stable. Any changes, we need to know about them. And the dissolved ozone sensor is making sure there's sufficient biocide in the cooling tower to reduce the risk of Legionella. So that's a closed loop system. That's the open loop system. The next picture you see underneath is of a portable version of the one on the top. We call it a site box. And this is for pre-commissioning of a system. So I've been to see many companies who employ facility management companies to come in and do pre-commissioning. Maybe you're doing some media work and you want to make sure you've got some continuous measurements. At the moment, spot tests have always been required in these instances. But when you do a spot test, you're just getting a one spot check. You write it down on a piece of paper and you're not getting the full data stream of what's actually happening. So we can supply and make sure that you've got a continuous version of the spot checks. And that is generating the data. It gives you evidence of what the pH, conductivity, maybe turbidity, maybe a biocide, all these different parameters that are modular, you can add or take them away, can give you much more information as demand occurs within a network. So take away the need for spot checks, make sure you get clarity over continuous measurements. And those are the types of sensors that we make and we are offering out in industry. Now, I know after doing some research that there's a company called HVAC that compete, or we compete with them. They've been quite big in London, but I believe the prices are very, very high. I think 16 to 20,000 pounds just to install these systems, and ours are about 25% of that. So these are more of an affordable solution that may be something more of interest to you guys. So that was pre-commissioning, and that's a portable version of the fixed units. One of the applications that obviously is quite big is district heating applications. And these are becoming more and more prevalent. Obviously now with more houses being built, where you've got a central system feeding many houses or many offices or many blocks, maybe it's a shopping center, etc. And we were doing some work with E.ON in London, and they were spending a lot of money on the pumps they were using. They were on continuously, and they didn't understand why they were using them so often, and they found there was issues with the water quality. So water quality, measuring continuous water quality accurately, gave them a lot of information. They cut back with the power on the pumps, and they saved about 50% of their power at one of the E.ON sites in London, which was a lot of money. So when you look at areas like district heating, massive potential for saving money. So what information do you get off these sensors? Well, we're a company that makes sensors for the water industry. So we make all the sensors. We don't often supply things like dissolved oxygen into the water industry. It's usually chlorine, whether it's free, combined, or total. It's usually turbidity for discoloration. But for the networks in a building, you are more interested in dissolved oxygen. And that's number one, reducing the risk of oxygen in the system, therefore rust, therefore corrosion, therefore potential of breakdowns. pH and conductivity. We are looking at a stable reading of both of these parameters. If we have a stable reading of these two parameters, we know that the inhibitors we're using, the chemistry that we've adopted into the pipework is constant. There's no changes. There's nothing to worry about. Pressure, of course, is an indication of a leak or a burst. If there's a drop in pressure and it's not positive, of course, is an issue. Turbidity, if you're looking for levels of biofilm in the system, are quite important. If you're knocking off bits of rust, if there's particulate in there, that's going to absorb the heat, and therefore it's going to increase the cost of heating the water or cooling it also. And then, of course, we have the biocidal sensors like chlorine dioxide, chlorine, ozone, bromine, hydrogen peroxide and peracetic acid aren't always that big, but these are the types of sensors that we make, and you can add to the suite of sensors. I thought I'd show you a bit of data in terms of some of the work we've done with companies down in London. So the first slide on the left-hand side is of dissolved oxygen. We also had pH and conductivity, but the green curve on the first slide, one of the issues with dissolved oxygen in a system is that you're trying to take it all out. And as a manufacturer of water and gas sensors, we don't like to see zero. Zero could be it's working really well or it's broken. So for dissolved oxygen, if you're reading zero and it's flatlined, we need to make sure that everything's working fine. And we went to site and you can see that green line going up to about 11.5 ppm. That's us taking the dissolved oxygen sensor out of the flow cell and showing it air. And that's how we calibrate the dissolved oxygen sensor. So at the temperature, I think it was about 21, 22 degrees at the time. When we pulled the dissolved oxygen sensor out, it went to 11.5 ppm, which you can see on the graph in the electronics is absolutely perfect. The other three slides are of the pH and the temperature and the conductivity. We had issues on site and we thought it was earthing because sporadically, every day at a certain time, the graph went crazy. We went and investigated, and it was a bit of a surprise that all three did the same thing. We checked the sample, everything was fine, but there was something happening at about 11:30 or something at night time. And that issue was recurring. And we found that there was an issue on their site with the chemical dosing. So these, the data does give you good information. This is just one example of many that we can come up with. So this is a type of data you can get from continuous monitoring. Who would value this data? Well, companies such as facility management companies, they offer a solution to operate your site, and they can offer service agreements to maintain their systems. So if they're dosing chemicals and they want to make sure that there's the right inhibitors, that there's the right oxygen scavengers, they can adopt these systems and look after them. Estates in hospitals, they maintain their water network as well. And we're doing some work down in Reading with chlorine dioxide, and they want to keep a residual of 0.4 ppm. So if you can think about a network in a hospital, they have in Reading, they have 8 big blocks from maternity through to the car park. And they want to make sure that when dosing chlorine dioxide in the basement, we get complete coverage of the complete network up into the roof space. So measuring things like chlorine dioxide in a hospital, could be bromine, it could be peracetic acid, it could be ozone, to make sure they get full coverage of the biocide. Pre-commissioning companies, I was seeing the picture there is of the portable site box. And again, you just plug that in, the water goes in through the sensors and back into the system. The sensors are safe and they've been regulated by the water industry as safe sensors for the water to go back into supply. So you can connect the sensors up into the site box, it goes through a push fit, back into the system, and you're getting continuous monitoring with alarms and with reporting potential also. Consultants are now seeing that we have this alternative to the competition out there, and they're saying a lot of good things. So consultants will definitely value this type of data. Mechanical and electrical contractors have been awarded the contract, may want to use these systems for a month, 2 months, 3 months to generate the right amount of data. End users, I mean, as long as they see value in paying a few quid for this type of system, then they will be interested. Unfortunately, not every building, not every company, not every organization can afford systems like this, even if they're only a couple of grand. Care homes, libraries, some of the buildings that you relate to councils. But, if you're looking at saving a lot of money, if there is a risk of failure on site, I'm sure that could be considered. So the fixed and portable solutions that we supply, that we make for this type of industry, again, if you see that picture, the sensors are ultra low power, 3.6 volts. All the information is stored on the sensor. You can add the sensors or take them away. They're all Modbus RS485 connections. That little blue device that the yellow cable is plugged into is a telemetry system. So we can send that information to a cloud, anyone's server. If you want confidential data, the systems are robust and you can fit them anywhere on a network within a building. We can also connect them to your existing BMS systems using Modbus, RTU, TCP, Ethernet. So they're easily contactable. And of course, the range that we make is quite extensive. The portable version is literally the fixed version in a box. You know, we make this system for the water industry. We engineered it for the water industry, where a treatment plant runs an independent sample to the case. It goes through the sensors and then back into supply or out to drain. And the reason the water companies wanted to do this is companies like United Utilities, who had issues with a pH monitor on one of the sites, they had an issue with cryptosporidium in one area. We are their main supplier under framework contracts, and we were asked to engineer a solution. This is the solution. And now we're looking at adopting and pushing it out to industries who may see value. So this is a portable version of the fixed unit. The sensors you can see from left to right are our normal fixed sensors that we've miniaturized and digitized. Maintenance, just to let you know, is very straightforward. Turbidity is a lens, just wipe it, it stays within calibration. ORP, dissolved oxygen, pH, conductivity, you clean the electrode or you replace the membrane on the galvanic DO sensor, and the rest is normal maintenance. I've thrown a few slides in from the flow metering part. Badger meter, Badger flow meters, you probably, again, never heard of them. They're one of the biggest, if not the biggest in America, but not in the UK and not in Europe, but they are soon becoming more and more known. For the HVAC market, we can use clamp-on meters, you know, non-invasive. You don't have to cut into pipe work. You don't have to stop production. These were very, very good down at E.ON in London, where they just wanted to put a clamp-on meter on the outside of the pipe. They're very accurate, and you can use those with external RTD sensors. So the RTD sensors, you can measure the temperature going out and then temperature coming back in. And then you can work out how much power is used, how much energy is used, and therefore give you the status of the pipe work. Mix that with water quality and you've got a complete smart solution for the inside of a building. So again, these are the pictures of the portable solutions from Badger Meter. If you just think about simply clipping these onto the pipe work and letting the flow meter do its thing, it'll give you a lot more information. They're also used to compare the efficacy of a fixed device that may have been there for some time, where you may want to check if it works well, if it needs calibration. And again, these systems are supplied all over America, and they're starting to become a bit more popular in Europe. So that was it. It was just a brief presentation. I know it's early in the morning. I know it's Halloween last night, so I'm sure you're all out with the kids. I just wanted to make sure that, you know, we will be doing more of these webinars, and we'll be focusing on saving money out into industrial uses. Obviously now with power, with chemicals, we do all sorts of gas sensors that we know could help for health and safety. So I will be hopefully seeing you guys more and more with some good news and some information. I would love some good questions to see how valid this presentation was out in industry. So please, yeah, if you can send us some good questions, I would really appreciate it. Thank you very much for your time.
Great. Thanks, Tristan. We've got a couple of questions. So we've got a question from Alex Barlow, and his question is, what sort of sensor detection would you recommend for a heat recovery system operation to heat potable water?
Well, again, dissolved oxygen has always been the top sensor really for any network in a building. When I was doing a lot of research for this industry, the HVAC system, which is the only other system out there, they boast that they use corrosion sensors. So they would always say corrosion sensors in that particular application. But for us, if you're measuring corrosion, it's too late. If you measure dissolved oxygen, if you can keep oxygen out of that system, you improved you reduce the risk completely of corrosion. I know you get dissolved oxygen in the chemistry as well, but a very small part. So the answer to the question is dissolved oxygen, I would always include number one. And then things like conductivity and pH to make sure the chemicals are on balance. Corrosion for me would probably be at the end, because again, if you're measuring corrosion, it's too late. So dissolved oxygen is what I'd say for that answer.
Great, Alex. If you want to follow up with that, just take yourself off mute. Otherwise, I'll move on to the next question. No, right. So we've then got a question from Augustine Drowhy, and his question is, what kind of analysis or sensors do you use to monitoring biofilm in heat exchangers?
And biofilm, again, we measure biofilm in a network in the water industry with this discoloration. Biofilm is kept in a network, and when you change the shear stress, you release the biofilm and it comes out as discoloration. I would therefore use turbidity. So turbidity is something that you would measure biofilm with. There are biofilm sensors out there. Yes, there are. How effective they are, I'm not too sure. But there are biofilm sensors out there that can measure levels of biofilm. In my experience, biofilm is always going to grow. We did some work at Sheffield University with biofilm. It grows within 28 days. It's a very clever organism. So yeah, biofilm I would measure with turbidity, because once that comes loose in a network, you're now seeing it as discoloration, and a turbidity sensor will see that. And as your turbidity goes up, you're getting more and more. Changes of conductivity will also be the case, depending on the metals that are released. And then, of course, pH will therefore change because the water will have minerals in there as well. So there are biofilm sensors. Yes, they are. How good they are, I'm not too sure. But I would measure with our sensors turbidity for discoloration, which is releasing the biofilm, and then the changes in the chemistry, therefore, to keep an eye on the levels and what you need to do when you do get this biofilm in the system.
Great. Thank you, Tristan. Tristan, you spoke a lot and you referred a lot to large sites like hospitals and E.ON, etc. How applicable is this technology and affordable is this technology for smaller craft facilities?
It's a great question. And it's something that I was working with a company who knew, I mean, I was going to say HVAC are the competitor, and their systems are £16,000 to £20,000. And as a result of that, they only focus in big buildings in London. And I was looking at a way of reducing the cost a lot, so that every county in the country and every business and organization, and we're talking care homes, we're talking small places that they don't really see the value in spending so much money. How affordable are these systems? Well, you can get a dissolved oxygen sensor for 1,500 quid and the last 5 years, but what do you do with it? What's the return of investment? What's the risk of corrosion? Hospitals, when you compare Legionella is regulated. You need to do something. Legionella is regulated. Thou shalt do something with that. So in those instances, hospitals are spending a lot of money to FM companies to come in and do their work and run their hospital for them. So therefore, the value of supplying biocidal sensors in a network, in a hospital, is worth it. It's regulated. You need to do this. So it's affordable. when we look at smaller companies and the value of continuous water quality, I would like the industry, please, to let me know how much value there is for you guys, because what is the risk of corrosion and complete failure, to a smaller company? I'm not too sure. I'd like to think there was value in every company adopting this, but obviously there's a cost to it. The price of these systems, the modular, 1,500 quid for DO, you're probably looking at $3.5 grand, $4 grand for a complete suite of sensors. Now, is that affordable? Well, when compared to HeaverSure at 16 to 20 grand, yes, it is. But when compared to a company that spends nothing, no, it's not. So it's a very good question. I'd love to answer it, Ruth. I think every organization is going to be somewhere in terms of value versus risk versus remuneration. I'd love to know a bit more feedback from your chaps, because this is the first time we're really rolling it out into industry. I'd like to put a question out there to everybody, at the BFBI. What value do you see in continuous water quality? I know when you talk about tangible savings with power, mixing flow metering, definitely. Flow metering, and we've got one of the guys from Badger Meter in a different room to me today. And when he goes to sell the concept of flow metering and understanding where the energy goes, it's mainly down to water quality. Cavitational of a pipe, as it starts to get blocked, the pumps and the system works harder to generate the energy to get it to the right place. It's the water quality that affects the pipe work. So in reality, if you're measuring water quality and quantity, you're getting a full spectrum of parameters and value. But how tangible is that in terms of price and cost? That's the question that I have, really.
Yeah, and that's the question I have. And you've got to go away and do some more graphs
Yes.
find out what it is.
Yeah, definitely.
Great. Okay, we've got no more questions come in, so it just leaves me to thank you, Tristan, and to say that this has been recorded. It will be posted. Anybody that signed up and didn't manage to make the webinar, they'll be sent the recording and the slide deck. And thank you. Have a good day.
Thank you very much for having me, and have a good bonfire night. And I'll hopefully see you all again at some point soon.
Cheers.
Cheers now.
Goodbye.